Hi folks, welcome back. I hope you're all doing well. So this is a paper from the 2020 conference on computer-human interaction, and I was drawn to it because I've been following the debate lately over whether notebooks are a good environment for programming, whether they should be used in production, what all their pain points are. There are people arguing for why notebooks are great. There are other people arguing for why they hate notebooks. If you go do a search on YouTube, you'll find a couple of some very interesting talks that make the case both ways. So this paper that we're looking at today does a survey of data scientists, and from that tries to understand what the main pain points are in computational notebooks today. And the insight gained from that hopefully can inform the design and implementation of better notebook systems. Now, in some sense, notebooks are like read, eval, print loops or REPLs in that they let you interactively enter code and execute that code and then in real time view the output of that code. There are a couple of key differences though. The first one, of course, is that the whole thing is saved and it becomes a notebook and you can share it and so on. But more importantly, every piece of code in a notebook, which in notebook parlance is called a cell, can be executed out of order. Unlike traditional code, which you enter into a text file, where you can tell by looking at the code what order it must have executed in. In a notebook, you can pick a cell to execute completely out of order. And this one feature, as we'll see, leads to a lot of the pain points that we will see later on in this paper. The method that the authors follow in this paper is to do field observations and interviews and surveys with practicing data scientists. All right, so what did the authors find from all these interviews of data scientists? What were the main pain points? The very first one is just to get your data ready and in a form that it can be analyzed and explored in a notebook. You might have to combine data from many sources. They might be in different formats. It might be too big to do analysis on locally on your machine, and it might need re-uploading back up to the cloud with more computational resources. So just kind of massaging all that data and getting it into a form that you can work with it is itself a major pain point. Now, one could argue that is more a problem with data science in general rather than with notebooks specifically, but nonetheless, it is something that data scientists have to do when they're using notebooks. Another pain point, I think, happens to be because of the implementation strategy of many current notebook systems, which is that there's a server or a kernel, which is essentially the language runtime doing all the execution and analysis, and then there's a client, which is usually a browser. And you're passing code and data back and forth between the client and the server or the kernel, and it sometimes happens that the kernel dies and crashes. And in contrast to IDEs or local development where you just have one process, here you have a client-server architecture. And when things break on the server, the client is left hanging. Some data scientists mention that iterating between modeling and visualization is difficult in a notebook, and I find that somewhat ironic because iteration was supposed to be one of the key selling points of notebooks. But I think one of the underlying issues this might be getting at is that notebooks are not IDEs, and they still lack all the niceties that modern IDEs have in terms of autocomplete and finding definitions and finding usages or doing complex refactorings. It's for exactly this reason that many data scientists mention that they often sometimes start off with an IDE and then graduate into a notebook. The next big set of pain points happens to be around managing dependencies and reproducibility. Most real data science projects will require a pretty large list of libraries in addition to just the basic language runtime to get their job done. And notebooks don't have a good mechanism to manage this set of dependencies and then to encode it in a way that makes the entire notebook reproducible when transferred to someone else's machine. Now, when it comes to debugging, this story is pretty interesting because at the micro level, at the level of a cell, debugging obviously is pretty straightforward because it's just like a REPL. You can change the code in that one cell and execute it and see what went wrong or how the output changed. But if you want to debug a larger issue that spans many cells, you again run into this problem that a notebook is not an IDE. So you can't do things like set breakpoints or inspect variables at runtime, and you have to fall back on debugging using print statements. Another big pain point is around testing, and now we're beginning to get into the territory of the kinds of considerations that come into play when you think about taking a notebook you've created for exploration and using it for real production use. So most current notebook systems don't have a good affordance for testing. Now, there are more recent systems like NBDev, which are beginning to address this. It's also very difficult to do versioning with notebooks as they are today. They mix both code and the output of that code, and it becomes very hard to look at the diffs and tell when you change just the code or when the code was the same but the output happened to be different because your inputs were different. This is a good summary of the current situation, which is that notebooks are a really good fit for doing quick, interactive, and exploratory analysis on data. But when you do that, you're not necessarily thinking about software engineering best practices. Indeed, the people doing this are not always trained as software engineers. They have a very different background often. But it is exactly that set of properties that then makes it difficult to take the code of a notebook and run it in production for real. You could either take the notebook as it was and just execute it only with larger data and longer runtimes, but that is not a very stable way to do it. The alternative is to then write code from scratch that is more production ready. And obviously that's a lot more work. And this is where that property of non-linearity of code execution in notebooks really comes back to bite us. It is very easy to end up with a notebook where the order of execution of cells has a big impact on the output that you want. And since that order need not be linear, it's difficult by just looking at the notebook what the right way to execute it is. And that's one of the core reasons why productionizing a notebook is so difficult. The authors also did a survey of their participants, asking them how important various data science activities were compared with how difficult they were. And if you look at these activities in the shaded red box, those are the high impact activities that are important as well as difficult. So you see things like refactoring code, deploying to production, exploring history, by which they mean the history of execution within the notebook, and having long-running tasks. These are all things that are fairly important, but also pretty difficult. I personally was somewhat surprised to see multiple languages right at the bottom of the importance list, because in the little notebooking that I've done, using multiple languages has been really handy. And then if you look at the chart of how difficult various activities are, you'll see that the most difficult activity is deploying to production, along with exploring history, long-running tasks, refactoring code, or the lack of ID functionality in general. So that was a quick look at a paper that surveyed data scientists to understand and catalog and document their biggest pain points with existing computational notebook technology. And hopefully we can use this understanding to build better implementations of computational notebooks in the future. I hope you enjoyed that, and I will see you next time. Thank you very much.